guys, what's up? As we're getting into our seventh lecture and lesson, learning IP addresses for the CCENT, Cisco Certified Entry Level Networking, ICND 100-105. So if you guys aren't familiar and maybe you're watching through the middle, I passed my ICND1 really high, as I mentioned in one of the videos, on April the 2nd, which wasn't long ago. So I promised that when I passed it to two of my friends that I would do videos on teaching it, so that way it would be enough for them to be able to pass it without paying a ton of money. That being said, my background is in IT and been doing it for a while. So what's up, guys? What's up? Without further ado, let's talk about IP addresses. So there's something you need to know, or something that you're going to be very familiar with. If there's anything in this course you probably heard of before, it will be the IP address. You cannot get to the internet without an IP address. You cannot cross a WAN without an IP address. And you definitely have to know IP addresses for the ICND1, along with pretty much all the Cisco networking, security, you name it, all of it is going to be based around some form or fashion of IP addresses. So an IP address is considered a layer 3. I will go ahead and say that. Layer 2 is MAC address. Layer 3 is IP address. So when a device handles an IP address, for example a router or a layer 3 switch, which you can enable IP routing, it is considered a layer 3 device. If it handles MAC addresses and nothing above, it is considered a layer 2 device, which for example is your most modern or switches nowadays. There's a few people who use like layer 3 switches maybe at their core. And even to this day, people still prefer not to use layer 3 switches, as the router handles the layer 3 layer basically in a network. So okay, let me bring up a few windows here before we get started, if I can find my, yeah, there we go. So I've got two pictures here. So let's switch screens, guys, and welcome. So there is a thing called classes of IP address, and we're going to be mainly talking about IP version 4. And if you grasp IP version 4, IP version 6 is a little bit different, but really and truly, if you grasp 4 and how IPs work, you're going to be able to know how IP version 6 works. So okay, moving on. And we'll talk about more about IP version 6 as we go on through this video. So right there is classes of addresses that you really must understand. In this case, let's get a snip here because I want to be able to highlight some of this. So we're going to snip this. So alright, the things that you need to know for the ICND1 is your Class A addresses, Class B addresses, and your Class C addresses. And you need to know this range. But this isn't the only thing you need to know. And we'll talk about that later because it lists a 127. In a minute, you're going to find out that that is a loopback address. But it's still considered a Class A. But the loopback, the 127-001 all the way to 127.255.255.255 cannot be used as an IP address on a network, because it was reserved for the loopback testing. So remember this range for Class A. Remember that its subnet or subnet mask, which isn't listed here, is going to be 250. Oh, that's going to be way too big, so I'm not even going to attempt it. But the subnet mask for a Class A address, which isn't on here, is 255. So let's bring up WordPad. We're going to fix this actually. Let's bring up WordPad. There we go. Let's get this bad boy. We're going to bring it under and we're going to fix this. So Class A IP addresses are from 0.0.0.0 through 127.255.255.255. The subnet mask, or the default subnet mask, better yet, we're just going to call it subnet mask because this is the default, will be this for a Class A address. It doesn't list it on this, and I actually didn't catch it when I grabbed it, but this is very important to know what the subnet mask is. So let's go up in size. Go back down. We'll go to 12. That's fine. So moving on, Class B IP addresses goes from 128. As you notice, it follows right behind the Class A address range, but its subnet mask is 255.255.0.0, or later on you will learn in CIDR notation it could be considered /16 instead, and this one could be /8, but we won't go into that. CIDR notation will come in after subnetting. I will explain it, the CIDR notation, a little bit more during the subnetting and after it is the following video. I just want you to be able to see it so it's not foreign to you at this point, so I'll mention it here or there. So your Class C is 192.0.0.0- or through 223.255.255.255, and its subnet mask is 255.255.255.0. So you need to know, you need to memorize this range and what its default subnet mask is. You will also need to memorize this for the sake of it being, when you get to subnetting, basically for the sake of subnetting and networking in general. You will need to memorize this, and you will run into something that will reflect, or you will need out of this in the ICND1, or that will help you answer a question. I guarantee you something is going to be related to this in the ICND1, so if there's anything that you really want to learn, you will hear me say things to this extent, and this is one of them. Memorize the Class A, the Class B, and Class C. However, do not memorize your Class E, as you don't need to really know this, because they're not used, they're for experimental purposes, as it says here. And D, I recommend just memorizing that 224 is your most common multicast address. Now, with that being said, memorize that once you get above 223.255.255.255, no IP address can be assigned to a host, so you might get a trick question and it might have an answer, and you can do the process of elimination, and chances are it's a multicast address. So, with that being said, you need to memorize your Class A, B, and C, and memorize that your multicast, you probably won't even see the word D, is 224 prefix. This will be any digit usually. So if it starts with 224, memorize that it is a multicast address. You're not probably going to see a question that says 225 or 226. You won't find, everything's based around 224 in the multicast address range for your ICND1 and ICND2. So this would be the question that they would throw at you. Now, I'm not saying that they won't try to say, "Hey, you're assigned this IP address, or you put this IP address to a PC or to a network and it doesn't work. Why?" Well, obviously you could look at it and say, "Well, it's because it's a multicast address," or "Why can you not assign that IP address?" It's because it's a multicast address. So memorize these and remember that the multicast address prefix, the most common one, is your 224. And you won't have to worry about the subnet mask as far as your multicast address, as they will be fixed regardless. Um, but you will not see a subnet mask usually mentioned in any of that. So you don't have to memorize subnet mask on the multicast. All you need to know is that it begins with 224. And that's what I recommend. Just know that a multicast usually begins with the first octet of a 224. And if you don't know what an octet is, you need to go back to my binary video. So Class A, Class B, Class C, remember those. Memorize their default subnet mask, as this will come back up in another video that I'll release. If not before subnetting video, you will see it during the subnetting video. So there is a range of addresses that you cannot use on the internet that is reserved for private. And if you work for a big company, chances are you've probably seen one of these addresses. And if at home you ain't plugged directly to your ISP or it plugs into some kind of router, chances are you've also seen it before. So let's go ahead and X that out. No, we do not want to save. And what we're looking at is what they call private IP address range. Now there's still a Class A, as you see here. It's still a Class A. Let's go ahead and get a snip of it. I'm going to do a snippet of it so I can circle. As you can see, it's still a Class A, but what I want you to memorize here is that this is a private IP address range. It is reserved, so the internet cannot actually use these address ranges. It's strictly for internal use only. This is the most common between bigger companies, and they will subnet it down as needed, but you will usually see a 10 dot dot dot, basically whatever they make it. And this allows for the most IP. So logically, enterprises, when they're going to use an IP address, or they're actually physically selecting, they're going to select the 10 dot range because they have the most ability for growth, divided networks, and host, which you will learn in subnetting. Now, you have a Class B, and I've seen this one a few times. I'm trying to think which device I've seen it on, and I cannot remember, but I have seen it before. It runs from 172.16.0.0 to 172.31.255.255. So this is a really odd range. And its subnet is also odd. And it basically stops about halfway in between this octet, which you will learn in subnetting, and we can tell this simply by the subnet mask in binary. So this is an oddball address range, and if you memorize this, it won't hurt. There might be one question that you run into in the ICND1 at most, I think, where you would have to actually probably know the Class B range, if that. But you really don't have to memorize these entirely. Just have a general idea, because it's hard to memorize the Class B one. The others are fairly easy, in my opinion, but the Class B is the toughest to memorize it. I memorize it by the subnet mask in the starting 172. And then basically I imagine the subnet mask and I kind of link it together on how the 240 is, so I could tell the range that it's at. So we have Class A, Class B, which is the oddball one. Then we have this one's commonly used on your internal home networks, which is the Class C. A lot of times to get into your home router, it'll be 192.168.1.1 or 192.168.1.254, depending on the router or a wireless device, either or. Usually they're a combination of both. But most internal home networks use the Class C. Now, the reason why is because they don't expect many devices to be on there, and it will not have conflict, or it's less likely to have conflict with other. Basically, it's a quick way to identify that it shouldn't be on a enterprise network, and somebody would pick up on it a lot quicker. So enterprise basically separate itself from somebody taking their router that isn't very IT savvy. They take a router or something and they put it on the network at work on their network. Well, with the 192 scheme, it's not going to work. And that was, in my opinion, some of the intention behind doing the home networks, is they didn't really need a 10 dot. They wanted a 192 dot. And this helps identify a device also to the user for troubleshooting if you call, for example, Linksys or NetTrend or etc. So this is mostly used. You will see the A and the C the most. A mostly in your big work or enterprise networks. C will be in mostly like your small home wireless router devices. We usually use the 192.168. It's probably the first. I'm going to be honest, the 192.168 was probably one of the first addresses that I memorized as a private Class C, and the only reason I'd say that, or I memorized it as a common address, is because so many home networks, when I set up a lot of small home networks with the routers and wireless devices for people, it was always the 192.168.1.1 or .1.254 at the last two octets, either or, but it was always a 192.168 there. So you need to know that these cannot be used on the internet. So these ranges are basically forbidden to be used on the internet. They strictly should be considered private addresses used in internal networks. And with that being said, when you go to the internet, if you have something similar to this, then you are not most likely not accessing the internet through that IP address. Your IP is getting converted through something that they call NAT, and you will learn more about NAT towards the end of the course, but it will make all of this make sense on why your home network's a 192. But when you go to look at your IP address on a website, it gives you a totally different address, and that's the ISP, Internet Service Provider address that they provided you. And for example, I will show you mine here, because you basically will not get to see. I think you'll see who my ISP is, but that's no big deal. But you will not be able to see my actual true IP address on the internet with this information. So once again, I'm going to take a snip so I can draw, because I like to draw, man, if you can't tell. So here we go. I'm going to draw this. So as we can tell here, my IP address, or IP4 address as I shall say, is 192.168.10.4. 192.168 is a Class C internal address. So your router and your small wireless basically acts as a DHCP on your inside NAT on your device, and it assigns addresses to all your devices. Now, most of the time, you have a lot of host address with the 192.168, but most of the time, your small home routers are going to have a pool range of probably about 200 devices in most cases. And you can go in there and change that, but in a home, having more than 200 devices on its network would be nearly unheard of, and chances are it's not going to support the bandwidth of most internet connections nowadays in the United States. There is a few that probably could handle that, um, but home-wise, chances of having 200 and chances of using that, uh, basically running a switch or a router that's capable of routing that much traffic is not likely on a small device like that. For example, if you're running over 200 devices in your home, you probably don't need a small home router or switch because the CPU power is not going to be enough. It's just not going to have the power to do that kind of routing without lag spikes. So as we can see, my subnet mask here, which is automatically assigned by the DHCP. If you create a static IP address, and we'll talk about it in a minute, you will have to know the subnet mask, but it is possible that your DHCP can give the subnet mask to your PC. And my default gateway, which is usually your router or your basically last device that you go to before you get to the internet, in this case wireless, where mine is a form of a wireless router but it disabled the wireless. I think it's a TrendNet, to be honest. And you can see the DHCP is the same, so it's managing all of that. So my small router, which is, I'm pretty sure it is a TrendNet, is giving me an IP address, a subnet mask, and even the default gateway, you notice, is a private address. So I'm technically, when I go out of my router to the internet, or technically I'd probably go to the ISP first, the internet service provider, who assigns you an IP address to be able to access the internet. This will change when I go out, and you will learn about NAT in and NAT out. This would be considered a NAT in IP address, or NAT in address on the router. Now, it's possible when I go out to the internet, it will be a 128 dot something, or even lower than that. It could be 92 dot whatever they assign you, as far as an address. But I can guarantee you, because this is a private address, that this is not what my address will be when I go out. But I use a static address. If I didn't use static IP address, I would actually show you guys. But I use a static IP address, and for security reasons, I'm not going to show that in a video. But I can set something up like that similar on down the line as a home lab environment to show you guys. So this is the idea of how IP addresses basically work. You need to memorize the classes of IP addresses. You need to memorize the range of them classes, and you need to memorize at least get an idea of the private address ranges. Like I said, B will be the toughest to remember. So going back, the way that you get an IP address is you get your IP address physically from your internet service provider. Now, can you have internal assigned IP addresses? You can. So don't get that confused. You can technically have a IP address on your PC even though you're not able to access the internet. So the internet service provider provides you a valid public, the word public, IP address to be able to access the internet. You cannot access the internet with a private address, and if you plug in, chances are your ISP anyways is going to have your port dead. ISP basically runs cables all the way up to your home via fiber or telephone for DSL or etc. However you're getting your cables. It could be coaxial by cable connection also. So you also have what we call the network and host portions, and I will explain this a little bit, guys, but I'm not going to talk about it a lot because in the subnetting video this is going to hit strong on your networking, or right before the subnetting video I'm going to be talking about the network portion and the host portion. But for now, I want you to just get familiar with the layer and the IP address ranges. But your subnet mask, and like I said, just take this in. You don't have to write it down at this point until the video of explaining network and host and the subnetting video. The subnet mask, let's bring up the other one. This one doesn't show it. All right, here. The subnet mask identifies my network and my host portion in my address. For example, we will say N in this reference will be network, H in this reference will be host, class A would be an address of, and this, even if it's an IP address, this is basically what I'm trying to get. I'm trying to get you an idea. It is based on the octet because of the subnet mask. My first octet will be network, and then I'd have host, host, and host in the next 3 octets. And I'm not going to understand it. There is network and host portions. As when subnetting comes, I honestly think this is where I'd be wasting my time to teach you here, is it's referenced a lot more into subnetting. So class B by default and class A by default, without it being subnet, the default is network, 2nd octet host, 3rd octet host, 4th octet host. As you notice, 255 subnet mask 000. So I technically could say in the default, everywhere that there's a 255, it would have to be a network full octet. I say full because in subnetting you're going to learn a little bit different. And the zeros represent the host portion. Now you're going to see this in subnetting, but if I wish to convert this to binary, my entire octet will be of ones. It will be 1, 1, 1, 1, 1, 1, 1, 1. And if you translate that binary to decimal, it would come out to 255. Or if you translate 255 into the binary, which you will need to get used to doing, it will have all ones in that octet. 0 would have all zeros. So all my ones would mean that I have to keep the first octet, or the first octet represents basically my network. In this case, my network would be 0. If that was 1, it would be 1. Over here, if 127, that would be my network portion in the IP address. The rest behind it would be my host portion. So if I converted this entire address into binary and the entire subnet mask into binary, what I want you to understand is everywhere in the binary, when you line them up under each other, that I have a 1, you will carry that identical binary down, and that represents your network portion. Everywhere that there's a 0 represents your host portion, which you will learn can actually change. In subnetting, you change it. It's basically given to the end user or the end device. So the same thing would be here. We got a network, and like I said, if we convert to subnet mask, we would have all ones in the first and second octet. Our network address here would be 128.0, and then our host portion will be 0.0. Over here, our network portion, if we went to this address side, would be 191.255, would be our network portion here, and this would be our host portion, 255.255, and we know this because of the subnet mask, and plus we know the default subnet mask for a Class B address. Class C, we have 192, but let's first do Class C down here. Class C, I'll give you a minute. What do you think would be the network and host portion? So look at Class A versus the subnet mask of its Class A subnet mask. Now look at the Class B over here and look at its subnet mask. Now this is the Class C subnet mask. So if you answered network, three networks in one host, or network network network, or network.network.network.host, you would be correct. Now once again, if we converted this, it would have all ones in the first three octets, and the last octet would be our host portion because it's all zeros. So this would be in the 192.0.0.0, this would be considered our network, 192.0.0, and our .0 at the end, the last octet, will be our host. Same thing here, the first three octets will be our network, so 223.255.255 will be our network, and then the last dot, or 255, will be considered our host because it has zeros. So with that being said, I will mention this, as you will find out also in the subnetting. You will learn this a lot more in subnetting, and you're probably going to truly understand how this works. But for now, I want you to understand that the subnet mask represents where our network portion will be, and it will not, in subnetting, you will realize that it will not always stop on an entire octet. When you subnet, you can split an octet and borrow only from the host side, which you will learn in the subnetting lecture. But what I want you to understand is that all your subnet mask, even with a 240, if you convert it into binary, a subnet mask will always have to look something like this. Or actually, well, I'm just randomly putting numbers in here. I don't know if these are, I'm trying to make sure I do put enough ones. They will look something like this, and as you see, you should get an idea that something looks common here. These can be considered valid. Not that one. Valid subnet, which can be translated. I don't know if I have enough exactly, but giving you the idea, I don't think I have nearly enough. But visually, note that you cannot have a subnet mask like this. That is invalid. This is wrong. I'm going to put an X by it. It's wrong. This is wrong. This is wrong. This is wrong. And the reason that these are wrong, which I will go ahead and explain, is that in a subnet mask, your network portion's always set to 1 and your host are set to 0 in a subnet mask. But your network and your host portion can never basically cross over to its side. So wherever you divide it, it will be consecutive 1s and then consecutive 0s. It will never have, in binary, it will never have a 1 behind a 0 ever. And a 0 can never be in front of a 1 binary in a subnet mask ever. In a subnet mask, never. So remember, the word subnet mask, you can never have 1, 0, 1, any kind of mixture. It's going to be 1s consecutively, and then at some point there's going to be 0s consecutively. And they can't even alternate. When I say consecutively, it doesn't mean like 3 1s, 3 0s, and then 3 more 1s. Once the 1s stop and it turns, one of the bits turn to a 0, the rest has got to be 0 behind it going to the right. So I want you to understand that. That's part of the IP, understanding the IP version 4. So you do got what we call IP version 6. And as you've seen over here, I actually had an IP version 6. And I'm just going to show you guys, we'll talk more about it. I just want you to be aware of it. I have an IP version 6 address right here, what they call a link local IP version 6 address. And then you have what they call a global IP version 6 address, which we will learn much later on. from here. So you must understand IP version 4, and then IP version 6 will be more easier. You will find out that it's more easier to learn. But in some areas it can be a little bit tougher. As you can see, hexadecimal is involved in it also. So be aware that it's there. Now the reason that IP version 6 is there, it was created due to the lack of IP version 4 addresses that were starting to be used up entirely. And actually I missed one. I told you guys that, and this is over here, this is considered a class A address, but remember that this right here is a reserved loopback address. So this is actually considered a private address also to a certain extent, called the loopback address. And for example, this is a common way to test your NIC card in a PC, as we can see here. But even if I put up, actually, can't use 255, 254, you will see that I will actually ping it. 255 will not actually work. So let's do, but so we'll put 254 because 255 won't work, and we'll explain why later on. But no matter what address I put in here, it's a loopback address. This was a mistake. They lost the class A address by the ISPs to be able to put out like 16 million IP addresses. But be very familiar with the loopback address, and most people type it in as 127.0.0.1. And a lot of engineers on the lower level actually do not know, on the lower level, do not know that 127.0.0 is the same as 127.255.255.254 or anything in between. You will be shocked at how many people actually do not know that. But it is still a loopback address. So anything from 127.0.0.1 through 127.255.255.254 is reserved as a loopback address. So it basically cannot be assigned. So basically, for being assigned, it would stop at the 126 address range, .255.255.255. And then 127 will be reserved for the loopback. And then, as we learned in your Class B, although it says this range, it is considered a Class B, but your 170, what was it, 176? Let's see, we got it back over here. 172.16.0.0 to 172.31.255.255. That shows you how familiar I am at actually memorizing. I always have to sit down and think of the subnet mask. And then C, which is 192.168.0.0, is considered the Class C. So don't get tricked. They actually cannot be assigned. As you can see, it's in this range. They cannot be assigned by an ISP or internet service provider, or they're not supposed to. It's supposed to be reserved, and they're not supposed to, based on regulations. So just because it's a Class A, you will see this range. It does not mean that it can be assigned as an IP address by your internet service provider, or as what they will call a WAN IP address. Same with the Class B reserved. Same with the Class C. And anything above this definitely cannot be used as it's reserved or multicast address. So that is the idea of how basically IP addresses work. Now I will talk a little bit right here at the end. Before I end this, I will talk about CIDR notation, but before that, guys, if you want to view something online, there is an RFC 1918, and you can type it in Google, that talks about the classes of addresses. So you would just type in RFC space 1918, and I'm typing it in to make sure. And the first website I get is legit, and it will basically tell you about address allocation for private internets, which tells you the private addresses. So that could be a question. So RF 1916, let's put this on here. RFC 1916 references to private network or networks, private networks IP addresses. And these are reserved for private networks, and you can read this if you want to. You don't have to, but do understand this number and associate it to private networks or private IP addresses for networks. Now, they can't throw you something like this in the ICND1. I've ran into something very similar. So, I put 16. It's supposed to be 18. I'm sorry, guys. Oops, I'm so sorry. This is supposed to be 18. I hope I ain't been saying it wrong. So, RFC 1918. And then it'll also talk about class ABCs and link local addresses. So remember, RFC 1918 references to the address classes and even the private addresses that are basically reserved for private use. So now going on, I'm going to talk about CIDR notation. And CIDR notation is a equivalent to the subnet mask, and it's usually displayed behind the IP address, kind of similar to the subnet mask, but it's a quick reference, and I will give you an idea. I like to, because sometimes this gets confusing. So your subnet mask here would be /8/16 for this one, and then /24 for this one. Let me bring that back one. So, and if you change this to binary, a quick way to understand CIDR before we end this is, if I change this to binary, this is an octet, so it's 8 ones, so 8 network portion, 8 bits would be /8. Or rather, you think of it as a network portion in subnet when it comes to this. 16 would be 2 octets, 16 bits, 16 binary bits in the network portion. So if you converted this to binary, you would have 16 ones, and if you converted decimal to binary, you will notice that you will have 8 ones, dot 8 ones, and then the rest will be 0, representing the network, which is 16 bits. For a class C, if we converted this, it would be 24 bits with 1, telling us what the network, or the amount of network bits would be in the address. And 24 bits, obviously in a network portion, CIDR is /24. So all CIDR is doing, CIDR notation is the exact same thing as subnet mask, except it was basically brought on as kind of a little bit later on kind of ordeal. There's a little bit more to it than that, but I just want you to understand that subnet mask, sometimes you will deviate between these two. So understand that you got subnet mask and then CIDR, but in the end they are basically the exact same thing as what your concept should be at this point for the ICND1. They are the exact same thing. If I converted this to binary, all it is CIDR notations. Tells me how many binary ones I have starting from the left working to the right. And then the rest out of the 32 bits would be set to 0. So I'd have 8 ones, and then the remainder of the 24 bits would be set to 0. And that would give me the same thing if I converted it to decimal to this. Same with this one. I would have 16 bits as 1 starting from left going to right, and then my last 16 bits would be 0. And if I converted that to decimal, it would be the same as this. And here you should get the idea that 24 bits will have 1 in binary, and then the last 8 bits would have 0. And if I converted that from binary to decimal, I would get this right here. So in reference, it is the same. I want you to understand it's the same as a subnet mask. Learning anything through that or past that really at this point is not going to be beneficial for you passing the CNT exam or the ICND1 exam. So I'm not going to overload. I think the worst thing people can do is when you're taking an exam at a time is overload you with stuff you really don't need. But you will need to know that this is CIDR and how it works, as they might not give you the subnet mask, they might give you CIDR notation instead, and vice versa. Instead, in another one, they might give you subnet mask. So guys, I hope this helps you understand how IP addresses work and the fundamentals of them. Remember that a public IP address, or to be able to access the internet, you must have an ISP assign you a registered IP address to be able to access the internet, and understand your private IP class ranges. I will leave you with this, if we did not have private IP class ranges for the inside network and the way that NAT works, you would only be able to access the internet per one bought internet or IP address, one device at a time. But in most home networks, and by most I mean 99.99, you're going to have a wireless router and you have several devices accessing the internet at the same time, but only one assigned public IP address. And the reason you can do that is a thing called NAT and private IP address. And you will learn more about that later in the course and lectures. I hope you guys have found this video on IP addressing beneficial. I hope it helps you understand. If you have any issues or problems, please feel free to reply or comment below, or you can actually PM me and let me know what you have trouble understanding, and I will try my best to help you or help clarify that area. If you find any mistake, let me know, because sometimes for example, I caught that I made one little mistake a minute ago. I do it in the videos because I'm more looking towards teaching and actually crossing my stuff like I normally do in my mind. So if you ever see me make a mistake, I honestly probably making it because I'm not focused on that, but more about how I'm wording stuff and how to explain it. So if you ever see a mistake, please just PM me, let me know. I will correct it immediately when I'm physically able to. And if you guys enjoyed the video, please subscribe or follow. Any questions, please feel free to ask me. And I hope to see you guys in the next video preparing for your ICND1 and CCENT certification. Until next time, guys, see you in the next video. Peace.